In reverse engineering, .NET binaries were always considered easier target than the native ones. Given their internal structure holding a lot of information about the source, it was possible with tools like dnSpy or dnSpy to recover almost the original program text. Of course, one could obfuscate or even make the decompiler fail while reconstructing the source code, but it was still possible. My personal favorite being challenge called Backdoor from Flareon 9. One of the recent binaries was Insomnihack 2024 teaser Trompeloe. Checking the properties of the file reveals that this is in fact .NET binary, and loading it into dnSpy shows the intermediate language code. But if we compare the dnSpy output with what we see running the binary, something is not right. Running the binary, we can see the calculating text being printed. While checking the binary in the dnSpy, we don't see it. Magic? Not exactly. Now, .NET binaries are stepping up the game. With the .NET 8 feature Ready2Run, parts of the binary are compiled natively, making the tools we use and love partially useless. dnSpy, at least at the current moment, is not much useful for this. If we started in the debugging mode, putting breakpoints in the compute SHA-256 hash, dnSpy can break there, but the stack trace shows that we are coming from method named d. But this method has no logic, just return false. This is really off. This video is not about solving the challenge. It's about what we can do when our go-to tool fails. We use another one. In case of Ready2Run and inability of dnSpy to show us the code, we can use dnSpy. That, apart from standard code displaying categories like EL, C#, contains also one more, Ready2Run code. Picking that reveals extra code that was responsible for the magic that was happening. Since dnSpy does not have any debugger, that's why dnSpy was my go-to tool, we can use another great one, x64debug. Since this is a native code, we can use a native debugger. To follow the native code execution, we need a point of entry. Thankfully, there are two of those in this binary. First, after running it, it waits for the flag, so we could put a breakpoint on reading from console, one of the APIs. Second point of entry is that the thread sleeps between outputting the text. Let's set a breakpoint on sleep. Running the binary again, we break in a couple of places. But finally, one of the calls originates from our binary. Changing the frame in the stack trace shows us the code that is similar to the one in dnSpy. We can even see a value of 3E8, which is 1000 decimal, 1 second sleep time. From that point, solving the challenge is as hard as solving a regular one. In this case, thankfully, the mapping of characters is 1-to-1, so we can brute force all the letters and special characters to get the flag. Ready2Run is a new feature that was designed to make the startup time and JIT compilation less needed. As a byproduct, reverse engineering is a bit more complex, but where's the will, there's a way.